Hey, welcome back to part 2 of this series in which we're building a drip irrigation system. It's taken me a while to prepare this video because in addition to having to dig, about 500 feet of trench, we also had to deal with Tropical Storm Arthur, which dumped over 20 inches of rain on us in just a couple hours, and it caused widespread flooding around here. We're on top of this hill, so it didn't flood per se, but obviously it saturated the ground so much that I couldn't dig for a while. And it also washed a lot of the sand that I had already dug out of the trenches back into them, so I had to clean them back out, and it was just a big problem. And it also pushed a lot of the digging work into this hardest part of the year, which isn't great, but I've been working on it. And we're going to talk a little bit more about the excavation later. But first, I think what I want to do is go over the setup a little bit and the design, and show you how all that's laid out, and then we'll get into laying some actual pipe. Okay, so at the heart of most irrigation systems is what's called a solenoid valve. This is a Rainbird DVF, but they all operate under the same general principle. You've got a solenoid on top connected to a power source. When the solenoid is energized, the water flowing in to the valve is allowed to pass through to the outlet and onto whatever sprinkler or drip irrigation equipment that it's connected to. But when the solenoid is not receiving any electrical current, the water that flows in is blocked and prevented from flowing out of the outlet port. It's pretty simple on its face, but the way it works internally is pretty interesting, and I want to take a little bit closer look at that now. So here we have a Rainbird DV. This is a slightly different model than the one we were just looking at, but it works the same way. We're going to take it apart and see how it works. Normally there's 6 screws holding the bonnet on. I've removed most of them already. I'm going to pop these last 2 off so we can take a peek inside. Okay, remove the bonnet. And we've got a spring on top of the diaphragm. So take the diaphragm off, and now we can see inside the valve body. This is the valve seat. Water flows in here, but as you can see, it can't go straight through to the outlet. It has to make it up and over this lip and then back down and out, right? Like that. So the diaphragm is shaped with this bell on the bottom, and that bell sits on top of this lip and seals it so that when you have pressure, let's say a higher pressure on top of the diaphragm pushing down, this rubber part seals this and it prevents the water from flowing through. And the way they get the higher pressure on top is there's also water inside here, right? So normally when the valve is closed, when the solenoid is not getting power, there's water on top of the diaphragm and water below, right? Like this, okay? But because the water on the bottom is only pressing on the outside of the ring here, right? Think about it. If the water is coming in through here, it can only push up on the diaphragm in this area here, this small surface area, okay? But on top, water's pressing down on the whole thing. And because the pressures on the top and bottom are basically the same, there's more of a downward force being exerted on the top of the diaphragm than there is an upward force being exerted from the bottom, because if you have equal pressure but a larger surface area, the larger surface area is going to have more force. So because of that, normally when you've got water on top of the diaphragm and on the bottom, there's stronger pressure or stronger force, let's say, pushing down, keeps the diaphragm pushed down, seals this, the valve stays closed, water doesn't flow through, okay? But here's where the solenoid comes in. The solenoid is really just a coil of wire. It's an electromagnet. Remember that when you send electricity through a coil of wire, it creates a magnetic field. So you got a coil of wire in here. When you get power, or electrical current, I mean, coming through here and flowing through that coil of wire, it creates a magnetic field that pulls a iron plunger up. So that you can't really see it, but there's a plunger inside here, right? This is the bottom of it. When you get current flowing through here, it pulls that plunger up via magnetism. And what that does, I don't know how well this is going to show up on the camera, but there's a pilot hole here in the center, right here, okay? A little tiny, tiny hole. It's very small. That hole is lined up with this hole in the diaphragm. See this hole right here? Okay. And you see this hole right here? All these holes are lined up. So it's called the pilot hole. What this does, say you've got the diaphragm on there, right? So there's a hole all the way through here, and there's a hole here. Okay, so all those holes are lined up. Now, imagine that this plunger is pressed down. It's sealing that hole, which means water can't flow up through here. Okay, that keeps water above the diaphragm. That's why the diaphragm has water in it, okay, when the valve is closed. But when you send power, current through the solenoid, or to the solenoid, it pulls this plunger up, it opens that hole, and it lets water flow out from here, right? From in here, above the diaphragm. So now all of a sudden, you've got very little to no water above the diaphragm, but you've still got all that water pushing underneath. And that tiny difference lifts the diaphragm slightly. And when that happens, all that pressure from the flow of water coming in, however, you know, whatever, 50, 55 PSI, whatever's coming in, pushes the diaphragm all the way up. And then it allows the water to flow over and through and come out. So that's why when you send electrical current to the solenoid from the controller, it is able to just create a tiny crack basically in the diaphragm, a tiny space that then allows the flow of water to push it the rest of the way. So that's different than if you were using like a stronger mechanism to like open like the ball valve completely. Think about it, like this is very low current. It's well, it's 24 volts AC, but it's only using like a fraction of an amp to power this device. And the reason they can get away with that is because we're not trying to open some big valve, you know, mechanical valve in here that's holding back all this water. We're only opening this tiny hole, right? But that tiny hole is enough to relieve the pressure above the diaphragm and create that pressure differential that just lets the hydraulic force lift it the rest of the way. So you can get away with using very low amperage mechanism to open, you know, what's a relatively substantial amount of water. So that's the basics of how the valves work. Now let's look at how the valves are laid out in the garden itself. Here we've got a top-down view of the garden. This is the well right here, this tan square where we installed the PVB and all that in the last video. This is where we're getting our water from. And this green circle is the hose bib we installed in the last video. All these green circles are garden hose connections, hose bibs, and underground pop-up faucets and stuff like that. And we're going to install all those in this video. Then we've got the main distribution line. This is 1-inch PVC, all these blue lines. This is what's carrying the water to where it needs to go. And the black circles are the valves that we just looked at. Each of these black circles is a valve inside a valve box. So this is going to determine the zones on the controller, you know, like the irrigation zones, 1, 2, 3, 4, 5, 6, 7, 8 of them. We've got this zone is the first one controlling the stuff, the planters and lettuce tables and stuff that are on this concrete slab. We've got a zone coming down here for the southwest corner, 3 zones for this big center section right here. Most of this is under plastic right now. The soil hasn't been prepared yet, but in anticipation of preparing it, we're going to have 1, 2, 3 zones there for each of these 3 sections. Then the distribution comes down here. We'll have a hose bib here, and then this area down here south of these plots is where we're growing those marsh grass plants. And I need water down there. I don't need it to be automated. I just need to have like some kind of manifold or something with ball valves going to each pond where I can turn on and off the water that's going, like with a pipe just sticking in each pond, and fill them up when the evaporation's high, like in the summer. So that's going to be determined later how all that's designed, but I'm just going to stub it out right now, so we'll have water there when we do design that. Then the distribution goes back up north. We're going east here to put a pop-up thing, a water box. I'll show you that later in this video, so that we've got water over here, like by the big bird bath and the wildlife pond, and there's some beds over here that I can probably just put a sprinkler on, you know, because they're relatively shaded, so they don't need a ton of water, but they do need some water sometimes. So just having a garden hose over here closer to the east side will be nice. This is here going to this valve. These are the compost bins right here along the fence. And what I've noticed with the compost is it takes a lot of time to sit there and water it as you put it in, just with a garden hose standing there, because it's so dry sometimes, the dry leaves, the dry grass that you're putting in there. And you can't just throw it all in and then wet it, because you'll never get the water down into the bottom. So I'm going to eventually build some kind of like mechanism or setup to where each compost bin can be automatically watered. Like I'll probably have ball valves so I can water the ones that I want to and turn them off for the ones that I don't. But that's going to have a valve so that I can control it from the controller. Like if I'm out there adding compost, I can turn on this valve from the controller and, you know, be wetting that layer of compost on the bins. And then like while I'm out collecting other compost, then come back and the top's already wetted, and now I can throw the next in, and it just keeps wetting it. That way I'm not standing there with the garden hose trying to do it for hours and hours. So that's going to have a valve there. Then we're coming up here to a valve at the ramp bed. That'll just be regular drip irrigation. Then jumping back down here, when we're going to tee off to the west and then come south, here's a hose bib on the inside of the fence down here. Then we go under the fence and keep going south, and then west across the dip. It doesn't show up on here because it just couldn't fit it on this image, but the boysenberries are over here on the west side of the dip. So we're going to cross through there and set up a valve over there so that the current boysenberry rows and then the ones that I'm going to add later will all have their own drip irrigation. And I'm also going to put a hose bib over there so that I can hook a garden hose up in case I need to like water some perennials in a bad drought, or if I need to fertilize something, I just need some water output that's not drip irrigation. I'll have a hose bib over there. That way I don't have to walk all the way back to the house or even just back over here to get the water. So this is the basic setup of how the water's getting distributed around the property. Now, the main thing that we need to do in this video is install all this stuff. This is the plan for this video. It should go relatively quickly, except for one section that we're gonna talk about in a little bit. But let's go out now and take a look at one of the valve boxes that I have already set up. I wanna show you what that looks like. It won't take that long. And then we'll actually start laying some pipe. So we've seen how the solenoid valves work and how the water is distributed throughout the property. Now it's time to apply what we've learned and start putting it all together. Here we have a valve box. This is just a housing that protects the valve while it's in the ground. We're running into it with the 1-inch pipe. I've got two 90-degree elbows because I had to come up about 4 or 5 inches in height to get into the valve box, because the top of the box needs to be at grade, you know, flush with the ground. You know, if it's too low, it'll hold water and just, it's a trip hazard. If it's too high, the mower will hit it. So it's got to be kind of right at a certain grade. Underneath the box, I've got 4, maybe 5 inches of pea gravel. I don't know how necessary it is in our sandy soil because the drainage is already so good, but it just kind of prevents the valve from getting super sandy or from the box from sinking, you know, if it settles a little bit, and it just makes the drainage even better. It can't hurt. So I'm putting about 4 inches. If you had like really heavy clay soil, you might want to put more pea gravel, like 6 inches. I don't know, I would put more if I had heavy clay, but the box is sitting on top of that. The valve is not sitting on top of the gravel, just the box. There's a couple inches, well, let's see, how much is it? Maybe an inch of clearance between the bottom of the valve and the gravel. And so this 1-inch pipe is going into the valve. It comes out of the valve with another short 1-inch nipple. And then that's going into a 1-inch slip to male pipe threads, also 1-inch fitting. And the reason I'm doing that on this one is because this zone has the lettuce tables and some of these planters, which are going to use 1/4-inch poly tubing. They don't have that big 1/2-inch drip tubing like we're going to use on the vegetable rows. So I needed to put a pressure regulator to drop the PSI down to like 25, because if you send, you know, 50 plus PSI through that small poly tubing, it's just going to blow out all the emitters and everything off of it and mess it up. So you got to reduce it with a pressure regulator. And the pressure regulator has 1-inch female pipe threads on both ends. So you need male pipe thread adapters to plug into that. And then the other side of the adapters are slips, so you can get back to your 1-inch PVC. So it's like valve, 1-inch PVC into a slip to male pipe threads into the female pipe threads of the pressure regulator. Then on the other side of the pressure regulator, you've got another male pipe threads to slip adapter. And then from the slip part of that adapter, I've got 1-inch PVC coming out to a 1-inch, it's a 1-inch PVC to 3/4-inch PVC reducing slip elbow, 90-degree elbow, because I want to transition from 1-inch to 3/4 for the riser here. And this is just a short piece of 3/4-inch pipe with a cap on the top. It's eventually going to get cut off lower, but I wanted to give myself plenty of room to work later when we go to install the headers and everything, which we're going to do in the next video. But for now, we're just going to cap these and glue everything together. And once we get everything put to this, let's say, level, then we're going to pressure test it all and make sure that everything's good and we don't have any leaks before we start cutting these off and adding the headers in the next video. But this is the basic setup for the valve boxes. This is all just dry fitted right now. What I want to do is let's jump back to where we stopped in the last video, which was the short length of 1-inch that we've got capped off over there by the well. And we're going to lay the pipe in here and connect all this and glue all this together. And then from here, we're going to come off this 4-way and go east and get into the center plot and then the southwest corner valves. And we're going to install one of these valves together and dig it out and everything. I'm going to show you how it gets put together. It'd be a little bit easier to understand it if you see it put together, I think. So let's do that now. All right, now we need to tee off the pipe that we just laid and go south to a valve and valve box down here that's going to irrigate the southwest corner, those 6 rows. But before we lay this pipe, let's go ahead and figure out exactly where the valve box is going to be, because that's going to determine what length of pipe we need to put in. So I think the best way to go about this is to think from the end. And what do I mean by that? Well, I know that I want the header to start somewhere right here so that it can go west across the top of these 6 rows. So if the header is going to start here, then I need to transition from my 3/4-inch PVC somewhere right about here. Okay? And if that's the case, then I know that I'm going to have my reducing elbow here and I'm going to have 1-inch pipe coming this way. Now, I could put the valve box here, right here in this corner where it turns, where the trench turns, but it looks kind of cramped. And I don't really want to have a whole bunch of fittings right as soon as I go in or out of the box. It just makes it harder to work on. There's no reason to stuff everything together like that. So I think what I'm going to do is I'll have the 1 inch coming off here. I'll elbow and keep it 1 inch, and I'm going to come back like 2 or 3 feet right about where I'm sitting, and that's where we'll put the valve box so that it can come out of the valve box right about here somewhere, let's say. 1 inch, 1 inch, hit that 1 inch elbow, turn this way, and then reducing elbow up to the 3/4 inch pipe. So we're gonna put the valve box somewhere about right where I'm sitting. So let's say I was to put it right about here. It's about 2 or 3 feet in from the corner. Give us plenty of room. So the first thing I need to do is widen my trench a little bit because it's just not quite wide enough for the box. So let's see. Won't take much. Remember, we're putting about 4 inches of gravel underneath it, so we can go a little deeper than the trench is right now. This actually doesn't get mowed here because this is a walkway that's mulched. So it's not as big a deal here if we're a little high. It looks like there's about 3 inches of space underneath the box right now. I'll dig out just a couple scoops more just so we can get that gravel at a decent depth. Yeah, maybe something like that. Now let's put some gravel there. What I'm gonna do to keep the gravel from spilling out the sides, I'm just gonna take a little bit of that dirt that we just dug out and build like a berm here. Just a small one, same thing over here. Just to temporarily hold that gravel in. All right, now we can put some gravel in. See how that berm kind of holds the gravel? Otherwise the gravel just keeps spilling out. I'll put a little bit more in there. Yeah, maybe something like that. Okay. So now we know where the valve box is going to be. Now let's get a valve and put it in there, and then we'll know exactly how long to cut our pipe coming from the north. Okay, so we got that valve box glued up and ready to go. That's 2 down. This video is getting kind of long, so I think I'm gonna split it up into 2 parts because we've still got a lot to do and I don't want you to have to watch an hour-long video. So we'll be right back in the next one.